I am Somasundaram, Assistant Professor in Physics. Today's topic is superconductivity. So, in general, what is a superconductor? Superconductors are the materials that can conduct electricity without any electrical resistance. So, it means, unlike the more familiar conductors such as copper or steel, a superconductor can carry a current indefinitely without losing any energy. So they also have several other very important properties, such as the fact that no magnetic field can exist within a superconductor. So within the zero electrical resistance, the materials can conduct electricity are called as superconductors. So a superconductor is an element or a metallic alloy which when cooled to near absolute zero, dramatically it loses all electrical resistance. In principle, these superconductors can allow electrical current to flow without any energy loss. So this is the graph which shows in x-axis temperature, and this is in the y-axis for a tin element. So then first one is non-superconductive metal. The electrical resistance falls 0 Kelvin, whereas in the superconductor the electrical resistance falls 0 at a critical temperature. Okay, so the critical temperature is the temperature at which the electrical resistivity falls to 0. So there are two types, type 1 and type 2 superconductors. So there are 30 metals, pure metals, which exhibit zero resistivity at low temperatures, and those property of excluding magnetic fields from the interior of the superconductivity, we can call it as Meissner effect. So this effect we will see in the next slides. So when describing superconductors, it is the magnetic properties that are very important and essential. The superconductor is not a perfect conductor but a perfect diamagnetic material which gives you the zero electrical resistance. This is known as the Meissner effect. So in other words, the expulsion of a magnetic field from a superconductor during its transition to the superconducting state. So this is the experiment arrangement for the Meissner effect. Here the magnetic field lines of force which doesn't include in the property of the superconducting element. So here this is the superconducting element, and this is the foam container in which the liquid nitrogen is poured, and there is the repulsion of the magnetic field exists in the body of the superconducting material. This totally we can call it as a Meissner effect. So this is the equation based on the magnetic field, the time dependence of the magnetic field in a perfect conductor by the classical way of expressions. This del square dB by dt equal to 1 by lambda dB by dt. The lambda is nothing but the penetration depth, that is the London penetration depth, which is the important property of this superconductor. So there are classification. This is type 1 and type 2 superconductors. This is the graph. This is the superconductor in which the Tc is nothing but the critical temperature and B0 is the field, magnetic field. This is the normal superconductor for the type 1 superconductor. So I will explain you later what is the type 1 and type 2 like that. Then this is the graph which shows Tc for a non-superconducting state and a superconducting state. So this is the explanation. This type has a characteristics as shown in this previous slides in the figure. The dependence of the critical magnetic field on the temperature can be clearly seen. There's type 2, it was discovered in 1962. It has two critical magnetic fields, whereas one non-superconducting structure and another one is the superconducting state. So these are all some of the metals, the superconducting metals, and critical temperature in terms of Kelvin, and magnetic field in terms of Tesla, and the type 1, type 2, the nature of these. So these are the superconducting materials. So then this is the final one which gives you the applications, that is the superconducting topic that is very essential for the present world for applicative purposes like superconductive electronic applications. There are many thin film applications in ultra fast microelectronics or instrumentation. Then this is the train, maglev train. So magnetically leviated train. This is one of the beauty of the applications of the superconductor, that is in the developed countries and the developing countries, people are trying to use the trains, bullet trains, by means of superconducting applications, magnetically alleviated trains. Then another one, the magnetic resonance imaging. The medical industry, the people are scanning the internal parts of the brain. People are using this magnetic superconducting material for this imaging purposes. Then another one is very important, nuclear magnetic resonance, the NMR. Here the people are using to study about the both quantitatively and qualitatively to measure the chemicals, that is inorganic whereas organic compounds, to determine how the structure. Many chemists are used for this NMR spectroscopy. So these are the few applications of superconductors. Thank you.